Hello everyone, for today we are going to talk about the factorial designs, and today I'm going to tell you how does it differ in comparison to our experimental and non-experimental designs. Let's talk about that in this discussion. Before we proceed with our definition of a factorial design, let me first give you a sample study like we usually do. So back in 2002, there was this study to determine whether experiencing violence in video games has an effect on players' behavior. So I think this is a familiar study to you. This is something that I mentioned most of the time. However, there's a twist in their approach. Their results suggest that the answer is both yes and no. And why? It's because in their study, there were males and females undergraduate and they were assigned either to play violent or non-violent video games. And they found out that there is an interaction between the variables. When we look at the results among females, it doesn't matter if they play a violent game or a non-violent one, their level of aggression is low. But when we are talking about males, the level of aggression increases from non-violent to a violent video game. Hence, it is not only the type of game that determines your level of aggression, but also your gender. So there is not just one variable affecting our conclusion here, but this time there are two. That's the type of research we are going to talk about in this discussion. Okay, so let me introduce the factorial design to you. So in most research situations, the goal is to examine the relationship between two variables by isolating those variables within the research study, meaning you only want one IV and one DV and remove all other things that may influence your conclusions. So with that, we try to apply different methods of control that we talk about during our discussion about experimental designs. In real life, however, variables rarely exist in isolation. There are different things that may determine the results of our actions. There are multiple factors to consider. For example, weight loss may be related to diet, exercise, health, and a variety of other variables. For example, the type of your body and other biological factors. It might be a little bit misleading if our research is only about the effectivity of exercise, but also, if we can take into account these other factors, then that would be a better research. We are moving to another way of studying variables, and this time we are talking about a way to study two or more variables and how do they interact with each other to produce certain results. Now, let me give you another example study. So back in 2011, Ackerman and Goldsmith conducted two experimental studies comparing the effectiveness of studying text printed on paper compared to text presented on a computer screen. However, there's a twist once again, and what they did this time is, other than determining if you're going to read the material on paper or on screen, they also changed the schedule of studying those materials, and they divided that into two: fixed time or self-regulated time. Okay, typically, as much as possible, we encourage students to have their own hard copy of the book they're using because it might be more difficult for you to study if you are using soft copies of books. However, this time we are going to consider other factors that may affect our study habits, and that is the schedule of studying. In this upper left condition, these participants read the text on paper and at the same time they have a fixed schedule to follow. But these guys on this group, they had to read the text on screen, but at the same time they also have a fixed schedule to follow. They differ with the groups down here because the one on the lower left side, they read the text on paper, but they had to do it on their own time. And these guys on the lower right side had to read their materials on screen and they will do it on their own time. Now that you have a basic idea about factorial designs, time to define the meaning of factors and factorial designs. So when two or more independent variables are combined in a single study, the independent variables are commonly known as factors. You know that the study is factorial if the independent variables are being called factors. And the moment that we use the word factors instead of independent variable, it means that we are ready to combine the different independent variables to look at various combinations. So in the study I presented to you earlier, there are two factors that they are considering. First is the presentation. Will that be on screen or would that be on paper? And also the control of time or the schedule. Will it be fixed or would it be self-regulated? So a research study that make use of factors, particularly two or more factors, is called a factorial design. Okay, so here are some things that you will typically encounter when you read research papers online. I would like to clarify the meaning of these in order for your reading to be easier. So you would typically encounter something like 2 by 3 factorial design. So what is the meaning of 2 by 3? It means that there are two factors. It's called a two-factor design. It's because there are two independent variables here. Okay, so what's the meaning of 2 in the first variable? For example, your first variable would be on screen or on paper. Okay, that's why it's 2 here. Why is it that this one is 3? It means that the second independent variable has 3 levels. There are 2 levels for the first factor and there are 3 levels for the second factor. So how many combinations would you be able to make? In order for you to do that, simply multiply these two. So 2 times 3 is equal to 6. There would be 6 different conditions or combinations. So if you're going to perform more rigorous type of studies, you may come up with what we call a three-factor design. And with the three-factor design, it would look like this. There would be 3 numbers here. And in this case, the first variable has 2 levels, the second independent variable has 3 levels, and the third independent variable has 2 levels. In order for you to know the total number of conditions, let's just multiply all of them. So that would be 2 times 3 is equal to 6 times 2, that would be 12 conditions. So that's a harder experiment. That's a harder approach in comparison to the one above. Okay, so there are simple factorial designs while there are more complex factorial designs. Okay, now let's talk about statistics. And when we are doing factorial designs, we are looking at main effects and interactions. And what is the difference between a main effect and an interaction? Okay, first let's talk about main effects. So when we say that there are differences among the levels, meaning one group is different compared to the other group due to one variable. For example, gender has a main effect on the dependent variable. Okay, so when we say main effect, we're saying that a certain variable has an influence. So all independent variables may have their own influence or may have their own main effects, but sometimes the effects combine together and they form what we call an interaction. So there is an interaction when two factors acting together produce a mean difference that are not explained by the main effects alone. So in interaction, we are seeing a stronger effect due to the combination of these two variables. So an interaction exists between the factors when the effects of the one factor depend on the different levels of a second factor. And at first, this sounds a little bit confusing, so let me show an example to you later on. Here's an example of a factorial study. There are two independent variables here. And let's talk about gardening. So the first variable is the presence or absence of water, while the second independent variable is the use of fertilizer. So what are the combinations that we would be able to make here? For group A, these are the plants that will both receive fertilizer and water. For group B, they will only receive fertilizer but they're not going to be watered. For group C, they are going to be watered but there's no fertilizer. And for group D, they won't have both fertilizer and water. So we would guess that group A would be the healthiest plant, while those in group D are the plants that are not going to develop healthily. Even though water and fertilizer has their own effects on the growth of plants, we can say that they interact with each other. That's why group A would be better in comparison to other groups here. Here is another example and more psychology related. Okay, typically in abnormal psychology, we are investigating about the best type of treatment that we can give to an individual. Treatment can be medical or it can be psychotherapeutic. How can we combine psychotherapy with medical treatment? What we can do is try to determine if there are combined effects when combining medicine and therapy together, or would it suffice if we only have therapy or if we only have medication? For group A, they will both receive therapy and medication. For group B, they only have therapy but they don't have medication. For group C, they don't have therapy but they take medication. But for group D, they are the control group, hence they are not going to have both of them. So guess what? I think that group A would have the highest amount of well-being in comparison to the other groups. That's why in abnormal psychology, you can hear authors say that they are confidently saying that the combination of therapy and medication would be the best approach in treating an individual with a certain disorder. However, there are studies that would say that they think it's not necessary to conduct therapy anymore because medications work even without therapy. On the other hand, there are those that would say that they don't think medication is necessary because therapy is enough to help the individual. But most of the time, I would say that the combination of the two is the most effective approach in treatment. Let's try to visualize what I'm talking about. So we know that these two on the left are the two independent variables, and this would be our dependent variable. Now, there is a part here that overlaps between therapy and well-being, meaning this is the part of the dependent variable that comes from therapy. Okay, so some aspects of your recovery is explained by therapy. That's why we are confident that therapy has a main effect. But there are also some aspects of your recovery that comes from medication. So it has a unique effect as well. However, there is also an area here in the middle that represents the combination of these two, and that is where we can find the interaction between psychotherapy and medication. You may be wondering right now, if does it always follow that if there is an interaction, there's always a main effect? Well, not necessarily, because there are times wherein only one variable will have a main effect, the other doesn't have a main effect, but there is an interaction. And for me, that makes the analysis more exciting, because we would determine that in the absence of the other variable, variable B is not effective or does not influence our dependent variable, but when you combine it with other things, that's how it becomes effective. Okay, so sometimes only one variable will have a main effect, and sometimes both variables do not have a main effect. And don't always expect that there would be an interaction. So different studies may produce different results. Now let's talk about how do we visualize interaction and main effects when we are now plotting them in a chart. Okay, so for this example, we are going to talk about a hypothetical data wherein there's a main effect but there's no interaction. And look at this. Basically, what this chart is telling us is that if you read by using a screen instead of on paper, then there would be a lower mean exam score. However, the scores of those who had a fixed time and those who had a self-regulated time did not differ that much in comparison to those who had a fixed time. Their difference is only around 2 points, both on paper and on screen. So there is no noticeable interaction between the variables. So you might be wondering, how can we say that there is a noticeable interaction between the variables? The rule of thumb in statistics is that if the lines are parallel, then there's no interaction. But if the lines are not parallel, then investigate or look for interaction, such as this example. Now, the lines are no longer parallel, but rather they have their own directions, and that is one of our signs that there is an interaction. Now, how can we say that there is interaction, and how do we interpret this result? So basically, it's saying that if you are reading your materials on paper, then there's no noticeable difference between fixed time and self-regulated time. But when you now transfer to on-screen reading, those who uses fixed time, they don't differ that much compared to those who use paper, but those who are self-regulated and at the same time they use screen reading, then they are going to have a very low score in comparison to other conditions. That's the basics of interpreting interaction plots by using charts. Okay, so the rule of thumb is if the lines are not parallel, then perhaps there is an interaction. But if the lines are parallel just like this, then don't expect that there is a significant interaction. Here's another example of an interaction, and this time we are talking about the relationship between TV viewing habits of 5-year-old children and their future high school grades based on a certain study. So basically, they investigated the types of TV shows that children watch, either educational or non-educational. And at the same time, they also measure the amount of TV viewing, and that can either be small to average or large amounts spent in watching TV. So they discovered that if there's a low amount of screen time among children, there is no noticeable difference in determining their grades when they get to high school. But if we are talking about a large amount of time spent watching TV, we can now see a very noticeable difference. Specifically, those who spent a lot of time watching non educational shows, their grades are low when they get to high school, but those who watch educational TV shows, their grades are high when they got to high school, especially if they spent a lot of time watching those educational shows. So it's okay to let your children watch TV in the future as long as they're watching educational TV shows. Now that you have a basic understanding of the meanings of main effect and interaction, it's time for us to talk about the different types of factorial design. So similar with our other experimental and non-experimental designs, we can do factorial designs between subjects or within subjects. And today we are going to talk about what are the differences, what are the advantages and disadvantages of choosing a between over a within subject and the other way around. And I'm going to introduce what we call a combined approach or a mixed approach. Okay, so first let's talk about between subjects. For example, a 2 by 4. Okay, so how do we understand this again? There are two IVs, and the first IV has how many levels? It has two, and then the second IV has four levels. So how many conditions will this produce? We can do that as 2 times 4. Okay, so there will be 8 different treatment conditions. Now, a separate group of 30 participants would be needed in each of those 8 conditions. So imagine, in order for you to do this, you need to recruit 8 times 30 participants, or in other words, 240 participants in your experiment. And what if your experiment is 1 hour in length? Then that would take a lot of time and effort to conduct that experiment. So a between subjects design is best suited to situations in which a lot of participants are available, individual differences are relatively small, and order effects are less likely to influence our experimental design. Now, there are situations wherein we can combine both the between subjects and the within subjects approach. And how can we do that? Let's look at the mixed design factorial study. So a factorial study that is mixed design combines the two different research designs. So a common example of a mixed design is a factorial study with one between subjects factor and one within subjects factor, meaning you incorporate properties from both between and within subjects designs. In order for you to understand that, let's look at the sample topic down here. This is between subjects in a way that we have two genders, males and females, and there's no way for us to do this as within subject. But at the same time, it's also within subjects because the same group of males will go through CBT, will go through person centered therapy, and will go through narrative therapy. Meaning the same group of guys and girls will undergo therapy 3 times to determine if there are differential effects with respect to gender and with respect to the style or therapeutic approach. So it's a combination of between subjects and within subjects. Now let's talk about another example in factorial designs. Okay, so there was a study conducted back in 2015 wherein they examined the effect of a certain medicine or a certain drug on pain and pleasure. Okay, so there were 1,000 total participants, and half were given a placebo and half were given the drug. So 500 of them received the drug while 500 of them received a placebo treatment. So the participants were then shown a series of 40 photographs with some showing highly positive images, such as children walking with kittens, while some were shown highly negative images, such as starving children. So what they have to do in this study is that they have to rate the pleasantness of the picture after either taking the drug or the placebo medicine. Okay, so how do we interpret the results in this study? The higher the score, the more pleasant it is for them to be exposed to this stimulus. So look at this. An example of positive image would be a boy walking with a cat. Okay, and of course, that's very, very pleasant. So we expect higher scores. But If we are looking at pictures of children who are starving, then that would be very unpleasant, which means that we are expecting lower scores. And that came true with the placebo condition because they did not take anything that would alter the way they feel either pleasure or pain. However, when they have taken this drug, look what happened to them. When they are supposed to be happy, they're actually not that happy compared to those who have taken the placebo, meaning the drug was able to influence the way that they experience pleasure. Other than that, here's the interesting finding. It did not only hinder their ability to experience pleasure, it also hindered their ability to experience pain. Those who have taken the placebo drug, they really felt sad. They were able to feel the pain of seeing children who were starving, but those who have taken this drug, they were not that affected by the pictures that they have seen. So, in conclusion, this drug doesn't only make you less sensitive to pleasure, it also makes you less sensitive to pain. And because these lines are not parallel, we can say that there was an interaction. Here's another example. In order for you to appreciate factorial design, so a researcher manipulated whether participants would play a violent or a non-violent video game. One independent variable is the type of the game that you play. Other than that, they also sorted the participants based on sexes. So now we can see that because of that, we were able to produce four conditions. Okay, males who would play violent games, males who would play non-violent games, females who would play violent games, and those females who will not play a violent video game. So there are four conditions, and based on what we can see here on the screen, males who played violent games are those who are most likely to be aggressive. Now, what are the advantages of using factorial designs in research? So, on the left side, we can see here a typical experiment wherein we have a treatment 1 and treatment 2, and they don't use a factorial design because they're only looking at the effect of one variable. However, like what you learned in our previous lectures, there might be some variance due to individual differences, and because of that variance, our groups become unequal, and that influences our conclusion. So to reduce the differences, individual differences between our participants, what we can do is that we can further specify the grouping by doing it like this, the one on the right, wherein other than having treatments 1 and 2, they also group them according to age group, like younger participants, those who are in middle range, and those who are older participants. So that makes it easier for us to spot the effects of the independent variables that we are looking at and to determine which groups would be the most affected. Now we know that in experimentation, the order effects will influence our conclusions. I hope that you can still remember order effects. It's the effect coming from the way that we order our manipulation. So knowing that order effects can affect our conclusions, you can actually make a factorial study by counterbalancing treatments. And how do we do that? For example, in the upper part, they received treatment 1 first. So this is their first score before receiving treatment 2. So they were able to produce two scores with treatment 1 and treatment 2. However, in the case of the second group here at the bottom, they received treatment 2 first before getting treatment 1. So we also got two scores from them, but this time the order is different. So that's how you do counterbalancing to produce a factorial design. Now, how do we spot for order effects in factorial design? So here in this example, a result that was not affected by order effects. So look at this. Basically, in treatment 1, the mean score of both groups is in 20, regardless of the order of these treatments. And the mean score after treatment 2 is 30, regardless of the order of treatments. So because there are no order effects, we can confidently say that treatment 2 is better than treatment 1. Because even if we change the order of treatments 1 and 2, treatment 2 will always result to higher scores. So how are you going to say that there is an order effect in your research? Just look at this. This is an example of a symmetrical order effect, which means that in this example, after getting the first treatment, in the second treatment, you're going to have a +5 in your performance. Perhaps that can be due to practice effect. So in the case of group 1, they had a plus 5 in treatment 2. But in the case of group 2, they had a plus 5 in treatment 1 because they have taken treatment 2 first before taking treatment 1. So the second treatment administered is the one that suffered from order effects. That's why if we are going to look at this, there is an additional 5 points in their scores in treatment 2. Remember earlier, if there was no order effects, their score should be 30. But because of order effects, their score became 35. Now let's look at the bottom group here, or the group 2. Okay, so there is no order effect in this quadrant. It's just the same with the previous example. However, when they were given the treatment 1, since they already know the strategy, they had a 5-point increase in their points. So instead of simply scoring 20, their score became 25. And that is a symmetrical order effect. And remember, this is just a hypothetical data. Imagine what would happen if there are a lot of extraneous variables in this study. So let us try to imagine that by looking at asymmetrical order effects. When we say non-symmetrical order effects, there is no consistent increase in scores, but rather the increase in score may change from one group to another. Okay, so look at this. For group 1, after taking treatment 1, they had an elevation of 10 points in treatment 2. But in the case of group 2, although they also experience order effects, their elevation in scores are smaller in comparison to group 1. So look at this. Remember earlier that the score without order effect in this quadrant should only be 30. But because of practice effect, their score in this quadrant has become 40. And something similar happened to this one. However, this is just like the previous example. So it's not really affected by the order effect. So group 1 is the one that has been more affected by order effects, particularly non-symmetrical order effects. So what can you do in order for you to isolate the main effects and interaction effects from order effects? Perhaps you can replicate the study, or meaning you can do the study again in a different country, or in a different culture, or in a different time, in order for you to prove that the effects of those variables and their interactions will still remain true even if the setting was different. So that's why there's a need for us to replicate a number of studies in psychology to prove that our conclusions are accurate until today. So basically, that is what you have to learn about factorial designs. Although this lecture is a little bit complicated, I hope that this shed more light in understanding factorial designs, main effects, and interactions. That's it for this lecture. See you next time.